Hello, here's an example from homework for the hypothesis test for a single population proportion. Okay, so this problem says, only 11% of registered voters voted in the last election. Will voter participation change for the upcoming election? Of the 377 randomly selected registered voters surveyed, 49 of them will vote in the upcoming election. What can be concluded at the alpha is 0.01 level of significance. Right, so for this study, we should use a z statistic for proportion, or a z test for proportion. Okay, so proportion problems, if you see percentages or like you're going out of this, there are 49 successes. This is like a binomial kind of experiment. It's either yes or no kind of thing, right? This is a z-test for proportion. Okay, so the null and alternate hypothesis. So the null is going to be that p equals 11%. So you want to write it as a decimal, 0.11. And the study wants to see if the participation will change. It doesn't say increase or decrease, just change. So different. P is different than 0.11. Right, so now we do the calculations. So with StatCrunch, you're going to go stat, proportion stats, one sample with summary. Okay. So the number of successes is 49 out of 377. So we put 49 out of 377. We put our null is p is 0.11 and the alternate p is different than 0.11. Click compute. That gives us the results. So this z statistic is 1.239. And the p-value is 0.2152. 0.2152. All right, the p-value is greater than the alpha value. That means we fail to reject the null hypothesis. So those are our conclusions, or our decision. The conclusion is basically that there's not, when you fail to reject, there's not enough statistical evidence to show that there's a difference. Okay? So this one. So the data suggests the proportion is not significantly different, and there's insignificant evidence to conclude that it's different. Right? So it doesn't when you fail to reject a null hypothesis, you don't conclude that there is evidence that it's different. You conclude that there's not enough evidence to prove that it's different. So I know it's subtle, but that's what happens. All right, so let me show you how this is done with the TI. All right, so let's second quit here. We go to stat and we go to tests. We don't have any data to put in, and we want a one proportion z-test. Right? So p0 is the null hypothesis proportion, 0.11. X is the number of successes, which was 49. Yeah, 49. N is how many people were surveyed, which was 377. Then we choose the alternate hypothesis is different. Okay, so not equal to P naught. And then we calculate. And we get Z is 1.239, P is 0.2152. All right, same as with StatCrunch.